Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 15 video from the chapter of Heron's formula, I will be solving 5 practice problems. These are based on all the based on concepts of the entire chapter of Heron's formula. In the next couple of videos, I will be solving some problems so that you have a good practice of solving problems based on the concepts of Heron's formula. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay. So the first problem says that ABCD is a rectangle and P and Q are points on the sides AD and BC such that PQCD is a trapezium. PQCD is a trapezium such that area of trapezium PQCD is equal to 5 by 6 part of the area of the trapezium ABCD. And QC is to PD is equal to M is to N, then the lengths of PD and QC is R. Okay, so we have to find the lengths of PD and QC. Obviously, since AD and ABCD is a rectangle, and of course PQCD is a trapezium because PD is parallel to QC, and of course PQ and DC are not parallel. Now, now first of all, what is the area of ABCD, that is the rectangle ABCD? It is length into length multiplied by breadth, which is xy. Since the the length of the BC is given as x, and that is the length of the rectangle is given as x, and length of the width or breadth of the rectangle is given as y. Okay. Now, what will be the area of the trapezium PQCD? Applying the formula, it will be half into product of the sum of the parallel sides. Let's say the length of PD is P, and let's say the length of QC BQ. So then the area of the trapezium PQCD will be P plus Q, that is the sum of the parallel sides divided by 2 multiplied by the altitude of the trapezium PQCD is the width of the rectangle, because these are, since this is the angles, the interior angles of a rectangle are perpendicular or 90 degree, of course DC or AB is the perpendicular distance between the parallel sides PD and QC of the trapezium PQCD. So it will be the altitude of the trapezium PQCD will be y. Okay. And okay. So this implies we have the area of trapezium is given to be 5 by 6th part of the area of the rectangle ABCD. So we have y into P plus Q divided by 2 should be equal to 5 by 6th part of the area of the rectangle, which is xy. Y cancels out. Y cancels out. So this implies we get P plus Q is equal to 5x by 3. So P plus Q we get is 5x by 3. Okay, and also it is given, so we get the sum of the parallel sides, sum of the lengths of the parallel sides PD and QC as which is 5P plus Q, which is 5x by 3. We also know that it is given that QC is to PD is given as M is to N. So this implies QC, we have considered the length of QC as Q. So Q by PD as P is given as m is to n. From here, we can clearly say, based on the ratio, that Q, concept of ratio and proportion, Q will be equal to Q is to P is m is to n. Okay. And we also know that P plus Q is equal to 5x by 3. So we can clearly say Q will be equal to m by m plus n multiplied by the value of P plus Q, which is 5x by 3. This, after simplification, is 5x m divided by 3 into m plus n. Similarly, P, from this fact and this fact, we can say that P will be equal to n by m plus n multiplied by the value of P plus Q, which is 5x by 3. This is equal to 5xn divided by 3 into m plus n. So PD is, we have been asked to find the lengths of PD and QC, that is P and Q. So PD will be equal to P, which is equal to 5xn by 3 into m plus n, and QC will be equal to Q, which is 5xm divided by 3 into m plus n. So the correct choice is A. A is the correct choice. Now, if you have any question in my solution at any steps, if you think my answer is incorrect, I am applying the concept incorrectly, or I am applying incorrect concepts, or if I am doing any kind of silly mistake, then please feel free to let me know in the comment section. I will highly appreciate that. And if you have any question or any doubt in solving any problem, then also let me know. I will do my best to to address your query. Okay, let's see the next problem. ABCD is a trapezium where AD is parallel to BC. So AD is parallel to BC and AB is perpendicular to BC. Okay, and AD is equal to X and BC is equal to Y and DC is equal to Z. Then the area of the trapezium ABCD is. Now in the figure, this part was not given, I'm sorry. So this is the original figure of the problem. So we know the length of the parallel sides. We also know that one side, that the parallel sides is perpendicular to one of the sides, which is AB, and we know the fourth side, length of the fourth side DC as Z. Using this information, how we can find the area of the trapezium. Now the thing is that obviously we have to find, if we can somehow find the length of the altitude of this trapezium, that is the perpendicular distance between the parallel sides AD and BC, which is actually AB. If we can find the length of AB, which will be the altitude of the trapezium, we can find the area, because we know the length of the parallel sides. Okay. Now, if I draw a line from vertex A parallel to DC, let's say I am drawing a line parallel to DC from the vertex A that intersects the opposite side BC at O. So this is AO is parallel to DC. AO is parallel to DC, and so AO is parallel to DC, and AD is already parallel to OC. So this implies that AO CD is a parallelogram. So this will imply that OC will be equal to AD, and OC will be equal to AD. OC will be equal to AD, which is equal to X, and we will have AO is equal to DC, which is equal to Z. From this information, how do we find AB? AB we know, AB is one side of the right angle triangle ABO. So somehow using Pythagoras theorem, we must see if we can use Pythagoras theorem in the right angle triangle ABO to find AB. So we need AO, we know AO, AO is Z, AO is Z, we know BO. Now what we need to know BO. So what is BO? BO is equal to BC minus OC. BC is equal to Y and OC is equal to X. So then what will be in right angle triangle ABO, using Pythagoras theorem, we have AO square is equal to AB square plus BO square. This implies AB square is equal to AO square minus BO square. What is AO? AO is Z, Z square minus BO. What is BO? BO is Y minus X whole square. Okay, so this implies that AB is equal to square root of Z square minus Y minus X whole square. So we have found AB, which is the altitude, length of the altitude of the trapezium ABCD. So then clearly we can find the area of the trapezium ABCD will be equal to half product of sum of the parallel sides, which is X plus Y, multiplied by altitude, length of the altitude, which is square root of Z minus Y minus X whole square. So this should be the area. So the correct choice is C. C is the correct choice. Let's see the next problem. Question number 3. If the perimeter of a regular hexagon of area A is P, then which of the following is correct? Now you must the concept of regular hexagon, the relation between the area of a regular hexagon and its length of its side must be very clear. So what do we have? So this is a regular hexagon. Sorry, 1, 2, 3, 4, 5, 6. So this is a regular hexagon. So the length of, let's say if the length of each side of a regular hexagon is A, and this is the center of the regular hexagon. What is the center? The point of intersection of all the perpendicular bisectors of all the sides is the center. So if you join, let's say the center is O, if you join all the vertices with the center, we will have all these triangles forming are equilateral triangles. They are congruent equilateral triangles. So this whole regular hexagon, the area of the regular hexagon is being divided into 6 equal equilateral triangles. And if you draw perpendicular from the center to any of the side, this will be the altitude of the this will be if this is H, so each of these triangles, so let's say the regular hexagon is A, B, C, D, E and F. So in triangle, consider one of the equilateral triangle. We have 6 equilateral triangles, congruent equilateral triangles, and the length of each side of all the equilateral triangles is A, which is equal to the length of the side of the regular hexagon. So in triangle, equilateral triangle AOF, we will have H, which is the altitude of the triangle, we know will be square root of 3 by 2 into A, and the area of the regular hexagon A, B, C, D, E, F, the area of the regular hexagon will be equal to 6 times, since the entire regular hexagon is divided into 6 congruent equilateral triangles. The area of the regular hexagon will be 6 times the area of one such equilateral triangle. 6 multiplied by, and the area of one equilateral triangle is square root of 3 by 4 a square. So this is equal to 3 square root of 3 divided by 2 a square. This formula you must always remember, that the area of a regular hexagon of side length a is equal to 3 into square root of 3 divided by 2 a square. Okay. So now the area area of the regular hexagon is given as a. So a, if we consider a, okay, and also it is saying that the perimeter of the regular hexagon is p. Okay. So p, obviously, if we consider a to be, small a to be the length of each side of the regular hexagon, p is 6a. P is 6a. Okay. And this will imply okay. So area is 3 into capital A is equal to 3 into square root of 3 divided by 2 small a square. Now this is equal to, so in the choices you see the relations are given between the P and capital A, that is the area. So somehow we have to find the relation between the perimeter and the area of the regular hexagon. So area capital A is 3 into square root of 3 divided by 2 a small a square. Now small a square, a is, so this implies a is equal to p by 6. So this implies a is p by 6. Okay. So now the area becomes 3 into square root of 3 divided by 2 small a square, and small a is p by 6. P by 6 square. This is 3 square root of 3 p square divided by 36 by 2. If is, then which of all is correct? Okay. Square 24. Okay. So this is equal to this is equal to p square square root of 3 divided by 24. So this implies, what is p square? P square is equal to 24a by square root of 3. If I'm 24a by square root of 3 is equal to p square. Now if I multiply 24a by square root of 3, multiply both the numerator and the denominator with square root of 3, I have, this will be equal to 8a square root of 3. So I am getting p square is equal to 8a square root of 3. So definitely the correct choice is D. D is the correct choice. Now the choice 1 and 2, they are relating. We are having now, since all these multiple choice questions are single correct choice, single correct answer choices, so one of the choices, only one of the choices will be correct. So obviously choice D is correct. But if you need to know what will be P, so this implies P is equal to square root of 8a multiplied by square root of 3. This is equal to 4 into square root of twice a multiplied by square root of 3. So P is 4 into square root of twice a multiplied by square root of 3. So none of the choices A and B are correct in terms of P. In the choices A and B are relating P with A, and choices C and D are relating with P square with, in choices A and B we are having a relation between P and square root of A, and in choice C and D we are having relation between P square and A. So choice D is correct. First A and B and C choices are incorrect. Okay, let's see the next problem. The length of the hypotenuse of a right angled isosceles triangle having an area A is. So if you have a right angled isosceles triangle ABC, Obviously the two arms are the equal sides. Let's say the length of the two arms or the two equal sides are a. Then using Pythagoras theorem, since ABC is the right angle triangle, we are considering it is right angled at B. So then the hypotenuse AC will be square root of a square plus a square, which is equal to square root of twice a square, which is equal to square root of 2 multiplied by a. You must always, this formula is also, you must always remember that for an isosceles right angle triangle, if the length of each of the arms or the perpendicular sides or the equal sides is small a, then the length of the hypotenuse will be square root of 2 multiplied by a. Okay. Now the area of the right angle triangle, the area of the isosceles right angle triangle is given as capital A. Now so A should be equal to half. Applying the formula for triangle, area of a triangle, half into base into height, we can use the two perpendicular arms as the base and height. So it will be half into A, which is equal to a square by 2. So from here we can say that a square is equal to twice a. This implies a is equal to square root of twice a. So now the perimeter is equal to a plus square root of twice a, which is we are not asked to find the perimeter, but we are asked, the question is asking to find the length of the hypotenuse. So the length of the hypotenuse is square root of 2 into a. So which will be equal to, so this is equal to square root of 2 into a, and a is square root of twice a. So this is equal to square root of 2 into twice a. This is square root of 4a. This is equal to 2 into square root of a. So the length of the hypotenuse is equal to 2 into square root of a. So the correct choice is B. B is the correct choice. Let's see the last problem. ABC and PQR are two triangles such that triangle ABC is similar to triangle PQR. So this is the symbol of similarity of triangles, that is three parallel horizontal lines. So it is given triangle ABC is similar to triangle PQR, which means that they have the same shape. The two triangles are similar when they have the same shape, but their sizes are different, which means that their sides are proportional. And it is given that the area of the triangle ABC is equal to k times the area of the triangle PQR, where k is greater than 1. So obviously triangle ABC is a larger triangle. Then the ratio AB is to PQ. So we have to find the ratio of the side AB of the triangle ABC and the side PQ of triangle PQR. Now one concept you must know that, so let's say if we have any triangle, let's say you have any triangle ABC. If you multiply if you enlarge this triangle, or let's say if you multiply all the length of all the sides, if you form a new triangle by multiplying the length of all the sides by some constant k, so all sides multiplied by k. So let's say the length of the sides of the original triangle is A, B and C. So let's say the new triangle formed is PQR. Obviously the length of QR will be k times small a, the length of PR will be B times small k, and the length of PQ will be C times k. Now when the sides, so what will be, let's say if the area of the triangle ABC, if area of the triangle ABC is A, then what will be the area of the triangle PQR? you must know this concept that the area of the triangle PQR will be equal to K square A, where capital A is the area of the triangle ABC. So when you multiply all the length of all the sides of a triangle by some non-zero constant K, then the area of the new triangle formed is K squared times the area of the original triangle. So and multiplying, and these two triangles, of course, triangle ABC will be similar to triangle PQR. So then so obviously the triangle ABC, we can see that the triangle ABC, since triangle ABC and triangle PQR in the figure in the problem, they are similar, and it is given that the area of triangle ABC is K times the area of the triangle PQR and K is greater than 1, then obviously the triangle ABC has been formed by multiplying the length of each sides of the triangle PQR by some constant, we don't know, some constant, and that constant. So obviously, let's say we must have okay. So obviously we must have AB, the length of side AB of the triangle ABC must be some constant, let's say C, some constant C times the length of the side PQ of triangle PQR. Since it is given ABC, triangle ABC is similar to triangle PQR, which means that we must have PQ by AB should be equal to QR by BC should be equal to PR by AC. The corresponding sides will be proportional. So we must have the side AB should be equal to some constant times PQ. Then if this is so, this will imply that also we will have BC is equal to BC should also be equal to C times QR, and we must have AC is also equal to C times PR. So from this fact we can clearly say that the area of triangle ABC must be equal to C square, as I just mentioned that when you multiply a triangle ABC, if you multiply all the length of the sides of a triangle ABC by the same constant, non-zero constant K, and then the area of the new triangle formed is equal to K square times the area of the original triangle. So in this case we must have area of the triangle ABC should be equal to C square area of the triangle PQR. But in the given problem it is given that area of the triangle ABC is equal to K times the area of triangle PQR. So we must have C square is equal to K. This implies C should be equal to square root of K. So then we must have AB is to AB by PQ is equal to we are asked to find the ratio AB is to PQ. So AB by PQ AB by PQ should be equal to AB by PQ is equal to C, which is equal to square root of K. So this implies that AB is to PQ is equal to square root of K is to 1. So AB is to PQ should be equal to square root of K equals to 1. So always remember that the concept is that if triangle ABC and triangle PQR are two similar triangles, that is the sides PQ and AB are proportional, that is the that is, we are having PQ by AB is equal to QR by BC and equal to PR by AC, then if we have the area of the triangle ABC is equal to, given as, if we are given area of triangle ABC is equal to K times some constant times area of triangle PQR, then we must have the length of the side AB must be equal to square root of K into the length of the side PQ, or the length of the side BC should be equal to square root of K multiplied by the length of the side QR. So, this is the concept. So, that is all in this video. I have solved 5 conceptual problems based on these are problems based on the concepts of the entire chapter of the Heron's formula. I will solve more problems so that I can cover most of the concepts and you have a good clarity of how to apply the concepts to solve this kind of problems. So, probably I will make another say 2 or 3 videos on problem solving based on the entire chapter of Heron's formula. So, if this video was beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.